All right, let's dive right in. We're going to do a technical deep dive into MindooDB. Now, this is an end-to-end encrypted, offline-first database, and it's designed to solve a really tough problem that I think a lot of us face in modern software development.
So everything, and I mean everything about MindooDB boils down to this one critical question. How do you build apps where people can collaborate when you absolutely cannot trust the server with their data? That's the core problem we're going to unpack today.
Okay, so here's the game plan. First, we'll lay out exactly what we mean by the untrusted server problem. Then, we'll get into MongoDB's zero-trust architecture. After that, we're popping the hood to see how sync and merging actually works. We'll check out the really cool features this unlocks and wrap up by talking about adoption. You know, the real-world use cases and the trade-offs you got to consider.
All right, let's start with the big one, the foundational challenge here. Look, we all build on cloud infrastructure, right? Which, let's be honest, is just a fancy way of saying we're building on computers that someone else owns. And since we don't control that hardware, that introduces a huge security constraint. So the whole philosophy behind MindooDB is built on one core assumption. You have to assume your server will be breached. It's not if, it's when. And when that happens, the attacker must only get their hands on ciphertext. That's it. The server's job is to store and sync encrypted blobs of data, but it should never, ever be able to read what's inside. This right here, this is the starting point, the absolute baseline for a zero-trust data model.
So how does MindooDB actually pull this off? Well, it all comes down to its zero-trust architecture. The guiding principle is super simple but incredibly powerful. It's your data, so they're your keys. And those keys, they never leave the client devices, ever. Let's dig into how that actually works.
Okay, this really breaks down the whole life cycle of your data into 4 key steps. First up, sign. Every single change is cryptographically signed. This proves who made the change and that it hasn't been tampered with. Step 2, encrypt. And this is critical. The data gets encrypted before it even thinks about leaving the device. Then third, it's append only. Everything is stored as a log that you can only add to, which gives you a complete tamper-proof audit trail. And finally, number 4, it's content addressed. This just means the sync is super smart. It only transfers the encrypted chunks of data that you're actually missing. It's wildly efficient.
Okay, so we've got this awesome security model. But how does this scale? How on earth do you build a collaborative system on top of this? I mean, how do you handle people editing things at the same time when all the data is encrypted and, oh yeah, people might be offline? The answer to that puzzle lies in the sync and merging protocol.
The secret sauce here is something called a conflict-free replicated data type, or CRDT for short. Now, if you take one thing away from this section, let it be this. CRDTs are basically magic data structures. They're designed so that edits from a bunch of different people, even if they're all working offline, can be merged together automatically, and they will always end up in the exact same final state. For us as developers, this is a dream come true. It means you get to just delete all that messy, bug-prone, manual conflict resolution code from your app. Gone. So when you put all these pieces together, you end up with a system that is just incredibly robust. We're not talking about it usually works features. The sync protocol gives you formal mathematical guarantees. Guarantees like you will always get all the data, period. Operations are idempotent, so running them twice won't mess things up, and it's order independent, so it doesn't matter if data packets arrive all jumbled on a flaky network connection. These aren't just things you hope for. They are provable, hardcore properties of the system.
Okay, so this is where it gets really interesting. Once you build on this foundation, zero trust, append only, CRDTs, you start to unlock some seriously powerful capabilities, stuff that's just not even on the table with traditional databases. First up, get this, time travel. Seriously, because every single change is part of this immutable, cryptographically linked chain. It's like having a perfect time machine for your data. You can rewind and reconstruct the exact state of any document at any point in its history. Think about how powerful that is for auditing, for debugging, or just for understanding how your data got to where it is today.
Next, let's talk about virtual views. This is basically a super-powered way to index and query your data. It lets you create these really complex hierarchical views, categorized with totals and counts and all that good stuff. But it all happens on the client side. And here's the kicker. You can build these views using data from totally different databases or sources. That's a total game changer for things like cross-company reporting, because you don't need a massive centralized data warehouse to pull it off.
And it's not just for text data either. The architecture handles files and attachments beautifully.
It does this by using memory-efficient chunking for both uploads and downloads. So what does that mean for you? It means you can stream gigantic files without completely crushing your device's memory. And because those chunks are content addressed, remember that from before, you get automatic deduplication across your entire system, saving you a ton of storage. All of this, of course, while still being fully end-to-end encrypted.
And this might be one of the most impressive parts. The sync protocol is totally agnostic to how your network is set up. I mean, it doesn't care. Are you doing a standard client-server thing? Cool. How about direct peer-to-peer over WebRTC? Yep. Or what about some crazy complex mesh network? It handles it. And the best part? You use the exact same API for all of them. So changing your entire network topology becomes a deployment decision, not a massive, painful code change.
Okay, so we've seen all these really powerful capabilities. The next logical question is pretty obvious, right? When should I actually use this thing? So let's get practical and talk about adoption. Because like any specialized tool, it's not a silver bullet. It has very clear strengths, and it has some very real trade-offs. This little chart does a great job of showing where MongoDB sits in the landscape. So compared to something you're probably familiar with, like Postgres or Firebase, the big win is that you're getting true end-to-end encryption and offline-first support, right out of the box, no custom logic needed. And then, if you compare it to blockchains, well, you get that same kind of immutable audit trail with high performance and, critically, with private data, not everything being blasted out to the public.
So here's the bottom line. You should be seriously looking at MindooDB, that's the green checkmark territory. If your non-negotiables include end-to-end encryption, you need those complete signed audit trails, and you absolutely have to have robust offline functionality. On the flip side, the red cross, you should probably stick with alternatives if all you need is simple CRUD over a reliable network. And one really important call-out, this is not the tool you want for doing complex relational queries on the server side.
Now, the good news here is that you don't have to boil the ocean to get started. Adoption is designed to be progressive. You could literally start in a couple of hours, just using it as a secure, local-only encrypted database on a device. Then, when you're ready to scale up, you might spend a few days to implement the sync endpoints and get a client-server model running. All that advanced stuff like peer-to-peer, you can layer that on later, incrementally, without having to do a massive re-architecture.
And finally, let's just put this right out there, because the project itself is very transparent about it. This is alpha software. That means while the core protocols are pretty solid, the APIs might change. For anyone making a technical decision, this is obviously a super important factor to bake into your risk assessment.
And that brings us to the end of our deep dive. You know, the architecture we've looked at today, it really does present a pretty compelling vision for where app development might be headed. So I'll just leave you with this final question to chew on. As data privacy shifts from a nice-to-have to an absolute, non-negotiable requirement, is a zero-trust data layer the future for your applications? It's definitely something to think about.